Hey friends, what we're going to look at in this lesson is solving radical equations. So we're switching from an expression to an equation. So an expression has no equal sign in the middle of it anywhere, right? Solving means we're answering math's greatest question, right? What is x? One of the things I want you to think about is when we're solving equations, you can solve them graphically and algebraically. Okay. Graphically, let's do that first. So to do this graphically, what I'm going to do is I'm going to say, I'm going to put what's on the left-hand side in y1 in my calculator, and what's on the right-hand side, I'm going to put in y2. Okay, so I'm going to pull up my calculator here, and I'm going to go to y equals, I'm going to clear out whatever's in there, and it said the square root of x plus 6, and in y2, I believe it said 8, just like that, and I hit graph. And my window settings are a bit messed up, so I'm just going to go zoom standard. Okay, my solution is where these two graphs cross, where they intersect. So right now, I don't see where they intersect. Okay, I can tell it's going to be, it looks like it's going to be over to the right. So when x is bigger. So all I'm going to do is I'm going to do this. I'm going to go and make x max really big, maybe like 100. And I'll change my scale to be really big, like 10. And now graph. And there I can see where they're intersecting. So to find that intersection, I go second, trace, intersect. And I just go enter, enter, enter. There it is. My answer is when x is 58. I see it down at the bottom of the screen. Now, what we're going to do, let's go do this thing algebraically. So we know the answer is 58. That's good. I know the answer. Okay, how do I show it? Well, what I'm going to say to myself is this radical is in the way. So the inverse of square rooting is squaring. They undo each other. That's what the word inverse means. So I'm going to square both sides. That way I'm not changing what it's equal to. I'm just changing how it looks, right? I'm maintaining equality. And now I subtract 6. Okay, 58. Easy. Now, what I could also do if I hadn't graphed it first is I could verify. So all I do is I take my answer and I say, let x equal 58. Okay, so I sub 58 into the equation. So on the left-hand side, I sub in 58. So I get 58 plus 6. That's 64, and the square root of 64 is 8. And what did I have on the right-hand side? RHS. I had 8. So guess what? Done. Okay, so you can verify your work. That's a good idea to do. Okay, the next one, 5 root x equals 35. So what I'll do first here is I'm going to divide both sides by 5 because the inverse of multiplying is dividing. So that's 7. And now I've got to get rid of that radical. So the inverse of square rooting is squaring. So I square both sides. That's 49. And if I wanted to verify, all I do, maybe I'll change pen color. Let's get some hot pink in our lives here. Okay, I sub in 49 to the left-hand side. Square root of 49 is 7, so it's 5 times 7. Guess what? That's 35. And I know we've done the question correct. Okay, so you should always, always, always verify. Okay, that will be incredibly important in the next lesson. I can't stress that enough. All right, one more, and then this is it. We're almost done this lesson. It's actually pretty easy. Okay, on this ugly looking guy, I notice everything's underneath my radical. So I'm going to square both sides. I'm going to square both sides, but notice I'm going to put that guy in parentheses like that, because if I don't, when I put it in my calculator, it'll tell me negative 16. But I know negative 4 squared is positive 16. Then what I'm going to do is I'm going to multiply both sides by 4, because the inverse of dividing by 4 is multiplying by 4. and then add 2. There it is, 66. Okay, and if I wanted to, I could quickly verify that. Let's find out. So switch pen colors, let's go dark green. Okay, so I go to verify this thing. So here's my left-hand side. Well, I sub in 66. So I'm going to get 66 minus 2 over 4. Well, that's 64 over 4. That's the square root of 16. That's positive 4. The right-hand side was negative 4. What the heck is going on? What happened is this. If we come back to the very beginning and look at the question, can a square root ever be a negative? Not in this form, it sure can't. So here's what happened, and here is why you must verify your work. This, we're going to cross off the answer, and we're going to write the word extraneous root. Meaning it's an answer that appears along the way, but actually cannot occur. Okay, so for this question, we have an extraneous root. We don't have any roots then. So then what we'll write to finish off this question is no solution. Okay, so again, this is going to be really, really important in this lesson and the next one. The term extraneous root means it's a root that works in the equation, but actually doesn't give us an answer. Okay, so we need to check for those always. All right, there's that one. One more lesson to go in the unit, friends. You're almost there.